Okay, so the next thing we're going to be covering is some universal programming principles, meaning we're not yet going to step into actual programming in Python. I'm just going to introduce some concepts that are there across all programming languages and certainly within Python itself. So the first thing we're going to touch on is a variable. So a variable is, you can think of it as a container for storing a value. So the variable there's some memory storage on the computer that is being used to store this particular variable. So a variable has two parts to it, basically. It has an identifier, which is the name of the variable, and it has the value, which is being stored in that variable, right? So the value can be a text, a number, or any other type of data. And in this picture here, what you're seeing is that this is the variable. The identifier for the variable is a score, and the value that's currently being stored in score is the number 12. So when you have a variable, right, you have to like define what that variable is. And so when you are assigning a value to that variable, what you're doing is your identifier is always going to go on the left, and then your value is going to go on the right with an equal sign between it. So in this case, right, your identifier is your score. Then you're saying is equal to the value of 12. Then after you do this, there will be some piece in memory that it knows that it's holding a number, and the value that the number that it's holding is a 12. These are some common rules for variable names. Most of these apply to Python, but I just want to give you like a general idea, right? So they should be short and clearly describe what the variable means. So our variable name of score was a good option, right? Something like this. Sometimes you do need a long variable name, but this is just too long. This variable represents player one score. Significantly long. You could potentially have score underscore player one, if that makes more sense. Very frequently, they have to begin with a letter and not a number. But then once you start with that letter, then it can contain numbers and some other characters like an underscore. Frequently, there are reserved characters. Here are some examples, and spaces are not allowed. A lot of times when you're writing the name, you could do it in camel case, which is right. So here your first word is lowercase, and then any subsequent word that's concatenated to it starts with an uppercase. Or you can have the underscore between it. And very frequently, languages have reserved words that have special meanings, and you should not use those words as variable names. Let's go through the different possible data types. One is a string, and though the string is any characters, right? And usually the way that you identify that something is a string is you put quotations around it, right? So once you have quotations around it, you could have spaces, you could have numbers, you could have characters, right? So here, this is my variable name, which is name. It's of type string, and the value it's going to have is this entire string, Alan Turing, as opposed to age, which you might normally think would be a numerical value. But here it's having the string of I am 21 years old. A numeric value, right, can take on, a float or take on an integer, right? So here my score 13, that's an integer. It only has whole numbers, as opposed to my average is going to have floats. And be very aware the difference between a quote and a not quote. So you can have, right? So once you put quotes around something, it's a string, and it no longer will be able to, you won't be able to do real arithmetic equations on it, right? So here, if I said x is equal to the number 5, and then I do x plus 2, my score will, as expected, be 5 plus 2, which would be 7. If on the other hand, I set X equal to, in quotation mark, right? So 5 plus 2 within a string is going to be equal to the string 5 plus 2 and not 7. Another basic type of value of a variable is a Boolean. A Boolean can take on one of two values. It's either true or false, right? So data science is great, true. I am bored is hopefully false. And then a list is, I think of it as like a container, right? So a container that can hold other values inside of it. Here I'm referring to it as an array, right? So it's holding other pieces inside of the list. Another universal programming concept is a conditional statement, right? So we kind of saw this a little bit already. I introduced this concept in flowcharts. That was that diamond, right? Where you're making some kind of a decision about how you're going forward. So a conditional statement, right? It will very frequently you see it as an if-then format. If this happens, then do that. Otherwise, do something else, right? So if a specific things happen, then this other thing happened. If you cross the finish line first, then you win. So that's considered a conditional statement. If the if statement is not true, then it will never get to the then statement, okay? Right, so this is showing you what it would look like if you have it as a flowchart, right? So if it's a correct answer, right? So this is your determination, then they get 100 points. As opposed to then, you could also have an else statement. So if you have your correct answer, then you get another 100 points. Otherwise, you'll lose 50 points, right? So this was, your Boolean is going to be here, and you're going to have, here you're only seeing two possible outputs of it. There's also you can branch yet again. You can say, right, so if this is true, then do that. Otherwise, else, if something else is true, then do that. And if that's not true, then do something else, right? So if the player gives the correct answer, then they earn 100 points. Else, if they answer 5 or more questions correctly, they could earn 50 points. Otherwise, they lose 50 points, although this is not equivalent to that, but I don't think that that is necessarily, that is a simple typo, which I'm sorry about. Let's look at some comparison operators, right? So most of these you'll be familiar with, right? Greater than, less than, greater than or equal to, less than or equal to. This is something that's a little bit different. Whereas the single equal sign is an assignment operator, right? Like store is equal to 12. You're taking the value of 12 and you're putting it into score. This is actually a Boolean statement. You're determining whether, here, if the first is equal to the second, right? So here you have 10 is greater than 5. That's going to give you the Boolean value of true. Then this is saying not equal to. So 10 is not equal to 5. That is going to be true also. And then 10 is less than or equal to 5. This is false, okay? 10 double sign equal would 5 would once again be a false statement. In addition to these more simplistic, you can have compound conditionals. So a compound conditional is when you're putting two logical operators together. So you're saying this and that, or this or that, or this and not that, right? So if something is, right, if you have something that's true and true, in order for it to be true, both statements have to be true. If it's false, if either one or both of an and statement is false, the or is true if at least one of your conditions is true, and the not is true only if it's not false, right? It turns a true to false and a false to true. one more depth is going to be your nested conditional. So, right, so this is, right, so here you're going on to another if statement. So this is saying if my pet is awake, if it's true, this is not going to an else statement. If it's false, then I'm going to, right, so my mood is asleep. If it's true, then I want to do another if statement. So this if statement, if the hunger is greater than 50%, if that's true, mood is going to be hungry. If it's false, then mood is going to be happy, right? So it's nested because you're doing first one if statement, and then only if that is true are you then going to a second if statement. Okay, there's two more universal concepts that we're going to be coming for. The first one is loops. This we saw already. Also back when I was introducing flowcharts. So a loop statement allows you to repeat a chunk of code many times, right? So if you want to add numbers together and you want to stop when you reach 100, then you could put it into a loop that repeats 100 times. So what this allows you to do is it does two things for you. First of all, it saves your time, right? Because you can just put something in a loop and it will execute 100 times. Otherwise, you potentially have to write the line of code 100 times. So it's a shorter line of code, and it also makes your program more readable and more understandable. And just conceptually, it makes a lot more sense. So when you're creating a loop, you want to think of these questions. What is it? What is the action that you want to repeat? And either how many times do I want to do the repetition, or at what point do I want to stop repeating what I'm doing? So like in this case, you would say, I want to stop when I reach 100, okay? So there's two main types of loops. One is called a for loop, and a for loop is where you know ahead of time exactly how many times you want to repeat your loop, right? So here what you're doing is you're saying, you're starting, and then you're saying, I want to repeat this loop for exactly how many entries I have within this list. So this loop is going to say, each time through, it's going to take a different value that's in the list. The first time through, it's going to be 1, 2, 3, 4, 5. Once it's completed that, it's going to go out to the end. You can say, so in this case, in essence, you're saying, do this loop 5 times, right? Another concept is a while loop. And whereas the for loop, you know ahead of time exactly how many times you're going through that loop. A while loop, what you're doing is you're saying, while this condition is true, continue staying within the loop. Then once that condition is no longer true, then fall out of that loop, right? So while the answer is not correct, ask the user, what is the name of the current vice president of the United States? And then print you are right if they got it correct. In a quiz game, you might want to ask the question until the user got the right answer, even if it took them 100 times. Okay, obviously this is, hopefully we would all get this right on the first attempt. Okay, the last universal programming principle that I'm going to be introducing is something called a function or a procedure. So those two terms, the function and procedure, are really interchangeable. So what is a function? So a function is a piece of code that you can easily use again and again, okay? So whereas a for loop, right, you're going to do it for the amount of times and it's going to occur in one specific place in the program. A function, you can say, like let's say you have 100 lines of code and you could say in the 5th line of code, I want to call this function and do this line of code. In the 20th line of code, I also want to run this particular function. So it's a chunk of code that you're going to be calling from numerous places within your code. A lot of the programs that, the programming languages that you're doing, you're going to be calling functions that come with the programming language itself. And in addition, you are going to be writing functions that will accomplish tasks within your code that you want it to accomplish. Right. So, and without a function, what you might have to do is, let's say your function is 3 lines of code. So you might have to repeat that chunk of code, let's say 4 times within your program. So rather than repeating that 4 times within your program, you pull it out, you create it as a function, and then every time you want to, in this case, do the jump function, right? Then you just call the jump function and it will do it for you, okay? Usually a function will have a name, okay? And then very frequently, you'll define a function looking something like this. So here we're defining function jump, and then these 3 lines of code are considered the chunk of code that my function is going to do. So when I tell you to jump, what I mean is move up, stop for a second, and then move back down to the ground. So if I have numerous players that I want to do the jump, every time I get a player and they hit the jump function, I say, go do the jump function, right? So here, right, when this is just showing, like, if you're writing a game program, so right, if player 1 hits the space bar, go execute the jump function. If player 2 hits the space bar, go execute the jump function, and so on and so forth. The concept being that it's a chunk of code that you always want to be executed in basically the same way, but from different pieces in your different parts in your program. To complicate functions just a little bit, sometimes you can pass a parameter into the function. And a parameter just means that instead of just executing the code exactly the same no matter where or when it's called from, sometimes you could pass a value into the function and it can execute internally a little bit different based upon the parameter that you have passed in. So in this case, you're allowing for our jump function, we're saying, well, instead of just presuming that we always want them to jump once, we can tell them that they could pass in the number of times that they want to jump, right? So in this case, if I call jump with a parameter of 3, then it's going to internally create my for loop, and it's going to say jump X times. So if 3 is passed in, you say jump 3 times. You can imagine if 1 is passed in, it's only going to jump 1 time. And last but not least is from a function sometimes, in addition to executing some block of code, you want to be able to return a specific value. So, if we go back to our adding 2 numbers using our long addition, right? So we might want to, within our function, take in the 2 values that we're adding, and then we might want to, the function would accomplish that long addition, and then it would return the value of the 2 addition. In this case, we're taking the average of a list of numbers. So you're calling that function with a list of numbers. So the parameter would be the list of numbers, because that could potentially change each time. And then the value that you're returning is going to be what your answer is of how you've calculated the average of that list of numbers. Okay, so these are, right, just what I've tried to introduce in this section, just some universal concepts. I haven't gotten specific to what they look like within any particular language, but they're concepts that really exist across just about all programming languages. You're now ready for the next step, which is going to be the next video. Is I'm going to start introducing you to Python, but the first video is going to be just helping you set up a very simple environment that you can work in Python that will all be in a very same environment.